We'll be reading the definition first. What is diffraction of light? It is a phenomenon in which the light rays, when they pass around the edges of obstacles or aperture, they come in a straight line, and after passing the round edges or obstacles or the aperture, they bend to some certain extent. They do bend to some certain extent. So this phenomenon is known as the diffraction of light, and this deviation also depends on wavelength of the light which is incident, and also the size of the slit or the aperture or the obstacle. Now we will do the comparison between the diffraction of light and the diffraction of sound wave. The light wave and the sound wave, the diffraction between them. I'm back. And then we have the comparison between the diffraction of the light wave and the diffraction of sound wave. So first of all, we have the sound waves matter. The wavelength of audible sound waves is 1.6 centimeter to 16 meter, and this is the range. So we can see the range is very high, and so even for a big hole in a line in which the incident ray is passing or incident ray is traveling, even if a big hole comes in that point, the sound wave bends from its original straight line of the incident ray. The wavelength of a light wave is very small as compared to the sound wave, so no noticeable change occurs in the direction of light. Relations after those dependence, the wavelength, the lambda depends, is directly proportional to the diffraction of light, and secondly, the size of slit or the size of aperture is inversely proportional to the diffraction of light. And then we have a small conclusion, a one-line conclusion. Finer aperture, more diffraction. Coming to the next page, we have the diffraction of light conclusion. First of all, light spreads like a wave. Light spreads like a wave, just like all other waves. Secondly, size of apertures larger than the wavelength of light. It causes the diffraction is not easily occur there, and so the light travels almost in a straight line as it was traveling in case of its own incident path. It was in a straight line, no diffraction, nothing, no change in its incident path. And in case of very fine aperture, this is a very rare case. So in case of very fine aperture, the incident light ray bends from its original straight line path, and this is the limitation of the geometrical optics. So rectilinear property of light is just an approximate behavior. The sharp edges of obstacle or aperture results in the diffraction of light being more distinguishable or detectable or identifiable. English. The diffraction also validates wave theory of light, but it does not give any information about the nature of the light wave. In case of the longitudinal or the transverse waves. Diffraction of sound and radio waves are more prominent than other kind of waves as the lambda are longer. I have already said it earlier. The lambda is directly proportional to the diffraction of the light wave. More is the wavelength of the incident light, more is the diffraction of the incident light. So in case of the sound and the radio waves, the lambda, the wavelength is very high, and that is why the diffraction in case of the radio and the sound waves are also very much high.